In this episode, I'm going to look at an almost forgotten about technology from like the 1980s when car stereos were really low power, and before the good amps hit the market, we had these devices called power boosters, which went between your speaker outputs of your stereo and your speakers to give you a little bit more kick. Let's take a look at an old vintage one from Radio Shack. What we have here is we have an early car booster. This is an early amplifier. This one was sold by Radio Shack. They claim 60 watts. That would be, I'm guessing, 60 watts total. So 30 watts per channel. And you have to remember back in the day when this was on the market, most car stereo head ends put out maybe 5 watts per channel. 5 watts of distortion. So this was a big step up to higher power car stereo systems. But they did things a little differently than, like made in Hong Kong, than the more modern ones. These ones here operated with the speaker level. Now this particular one does have line level inputs. Most did not. Most of them of this era just had your standard speaker plug, and you unplugged your speaker from the back of your existing deck, and you plugged it into here, and the inputs wires were wired to the corresponding wires that went to your existing speakers. These worked on a high level input, and I say some of them had line level input as well, but line level was not all that common back then. And I think what we'll do is we'll take this thing apart and just see what makes this thing tick, because it's completely different than anything modern, including the size of the screws that they use. Number 1 screws. What do we got on here for outputs? Is it ICs? Oh, this one's actually different. I was expecting this to use ICs, but this one actually uses discrete transistors. Interesting, because most of these did not. And it's got these funky transformers on them as well. And look, it was made by Nike. Most of these type of booster amplifiers used IC outputs. They used 4 ICs. One of them operating for the positive wire, the other operating for the negative wire. And how they operated was one was fed the signal into the negative input, and the other one was fed the signal into the positive. So one IC, you've got your 2 inputs to your power output IC. You've got a positive and a negative. On one of them, they would ground the negative pin and send the signal into the positive, and the other they would ground the positive pin and send the signal into the negative. So what you ended up with is you ended up with an inverted. So as one was rising in voltage, the other one was going the opposite direction, was falling in voltage, which gives you a bridged output on the 2 wires that went to the speaker. This one is a little different. This one's a push-pull current amplifier. Now remember, if you remember your basics in amplifier design, voltage, higher voltage gives you more capable power. So most amplifiers will have a voltage of maybe plus 60 volts and negative 60 volts for a good high-powered amplifier, or plus 40 and minus 40, because you've got a... Where was I? I keep getting interrupted by text messages at the most inopportune time when I'm trying to concentrate. In a conventional Class AB or Class B amplifier, you have a positive supply and a negative supply, and you step the voltage up. Modern car amps do the same thing. They'll have a DC to DC converter to change the 12 volts DC to an AC or chopped DC signal, which you can then run through a transformer, step the voltage up, and rectify it back to DC, and you'll have your higher voltage positive and your higher voltage negative supply. This does not do that. This one here, you're working with 12 volts. And since you've got a limit of 12 volts, there's a limited amount of power that you can get with 12 volts. What they're doing on this one is they are using transformers to step up the voltage on the output. So you've got 2 transistors per channel, one for the right speakers, one for the right channel, one for the left. This is the right channel amp, this one's the left channel amp. and the waveform is going through these two transistors, but each transistor is running at the full 12 volt potential. So this is going to be a class B amplifier, and distortion is not something that they even consider on this. These things are distortion kings. But basically how it's working is one transistor will conduct for the positive side of the waveform, the other transistor will conduct for the negative side of the waveform. Because they both work on the positive going, because you've only got 12 volts, you've got ground and you've got 12 volts. So one operates based on the positive swinging voltage, the other one based on the negative portion of the waveform, the negative swinging portion of the waveform. They're both working with positive. So as the transistor goes into conduction, you are working with the positive voltage. But to create that full wave, you have to use a transformer. And they're using the winding of the transformer to recreate that full waveform. In doing so, you can effectively double your output power that you would get from a single transistor, or even a class AB amplifier that's floating at 12 volts. So they're doing things a little bit different to try and get that higher power, and they're involving these transformers to do it. I think what we'll do here is we're going to hook this thing up and see if it works first of all, and maybe take some measurements of the signals going through the amplifier so that we can get an idea of exactly what is going on inside here. So I'm going to give this thing a line level input as opposed to a speaker level input from my MP3 player, because I can control the volume on that. And we've got the speakers hooked up here. One speaker to the white plus the brown, and the other speaker to the gray plus the brown, and the other one to the white plus the green terminal. Now, I don't know whether this one here uses a grounded output. Be interesting to see whether any of these speaker leads are actually going to ground on this one. But yeah, this one's actually using a common output. If you look at the gray and the white, they are both right to ground, so they are connected internally. But it is not a bridge tied load or a balanced output, as most of them were. So most of the boosters of the day, you had to have a pair of wires running to each speaker, whereas this one here, they can use speakers that are commonly grounded. A lot of factory car radios, they only ground one wire to the speaker, the positive terminal on the speaker, and the negative terminal was grounded to the vehicle, and that provided the return path. But this one here, because of its design, both of the negative pins are grounded together like a conventional amplifier. First thing you notice on an amplifier like this is that the heat sinks start to get hot right away. And they get quite hot even when there's no sound, because an amplifier like this is operating, each of these transistors has to basically operate as a class A amplifier, because you don't want them cutting off. So even when there's no current flowing through, or no music playing, there's still a fair bit of current flowing through the transistors and through the transformer itself. So that and they're balancing each other out. So if we take every time I talk, I get interrupted by phones. So if we were to take a look at some of the voltages here on these transistors, we'll see that there are voltages on the transistors themselves that keep the transistors biased into a state of conduction. So they're in a semiconductive state right now. So if we look at the transistors here, we'll find that we get a ground on this one. Okay, we got 14 volts here. We got 0.5 that keeps that transistor in conduction. And then the other transistor over here, we've got 14.5, 0, 0.78, and 13 volts over here. So the transistors are this one's in conduction. This one here is just biased slightly on. Same goes on this side here. 14.1 versus 0.4 or 0.04, 13.58, and on this other side over here, 0, 13, and 0.5. If we start playing the music, we're going to put the scope under so we can see what the actual transistors are doing. Now, if we remember, when we measured the voltage here, and I'll show you the scope in a minute. I only have one camera here, so I can't show it to you at the same time. But if we remember, when we measured the voltage here, we had 0 volts on, I think this is the emitter. Collector, we had 14 volts, which just so happens to be, that's what my power supply is set to. I put this at 13.8. Okay, there's our 13.8 volt supply. 0, 13.8, 0.5, that's the base. On the other side over here we had 13.7, we had 0.06, and we had 13 volts here on the base. If we look at the signal, there's nothing here. I'll show you the scope in a minute. All right, that's the emitter. We have audio on the collector, but remember there's 12 volts or 13 volts on there, and we have audio going into the base. Over on this side, we have nothing showing on the scope. This is the lead that had no voltage on it, but we have audio on here, and we have audio on the base. Let's take a look at the scope. So if we look here, this is again, here was the emitter, there's no voltage, 0 voltage, there's no signal there. Here's our collector that had the 13.8 volts on it. And here's the base. This is the transistor on the left. You can see the input there, it's much lower, but there is a signal there. And the other transistor, again, the voltages on this one were 13.8, 0 and 13.1. So here's the one that measures 13.8. As you can see, there's no signal on it, just DC. Here's the one that's at 0. Here's the other side of the waveform. And of course the base, which has voltage on it as well. So they're keeping the transistor biased on, which is producing a fair bit of heat, and it's drawing about a ½ an amp of power. Even when there's no sound, it's drawing a ½ an amp of power, and that's just dissipating that ½ an amp as heat, as you can see on the power supply. If I increase the volume, the base, the other transistor, if we look at the outputs, I've got 2 scope probes connected both to the collectors of the 2 transistors, and we'll see when I put tone on here. It's not exactly clean. Look at the little spikes here. We increase it. Now we're getting into clipping. Pretty nasty distortion there. But can see both transistors are actually running in phase with each other, but one of them's got 12 volts DC present and the other one is sitting at 0. So this amplifier is operating as a parallel driven, it looks like a parallel driven single-ended, and they're combining the two waveforms together in the transformer to double. I don't have a schematic. This would be an interesting one to see how they've wired this thing up. I've been looking and I haven't been able to locate a schematic for this thing yet, but I can tell you that even with no signal going through the amplifier, with it sitting with no signal at all, the heatsink actually is very warm, almost hot to the touch. Actually, it is hot to the touch. If I put a temperature probe on here, you'll probably find this thing's running in around about 60 degrees centigrade. It is very warm, and you can't keep your fingers on it for more than a few seconds. To try and make this thing a little easier for you guys to understand, I've simplified it. I've just drawn the output stage. So the two output transistors, we have one NPN transistor and one PNP transistor. The emitter, which is this one here, right? You can see it's labeled. I should turn the power off on this thing before I blow myself up. You can see this one's marked E for emitter. So you've got your emitter, your collector, and your base. Emitter, collector, base. Same as over on this side over here. Emitter, collector, and base. Here's this capacitor that's in line between the two collectors. So this is how they are wired. The emitter, this is off of the 12 volt choke. 12 volt comes in here. There's the input choke. This is to remove any alternator wine and stuff. This is just a choke coil. The 12 volts comes in and is applied to the emitter of the PNP transistor, which is right here. Okay. The collector of that transistor goes into one winding, one primary winding of the transformer. The other side of that primary is going to ground. The other transistor over here, the collector here, right at this point, that's where the other winding of the transformer is connected, right here. And in between the two of them, there's this blocking capacitor. The other side of this transformer, the other end of that primary, goes to 12 volts, which is connected right here. And this ground wire is connected right there. That's the ground wire there for the transformer. So what we have, and then the driver stage is just a conventional type of driver. But what we've got here is we've got these transistors that are biased on slightly, so that there's always some current flowing through this transistor into this winding of the transformer, and there's always a little bit of current flowing through the transformer and through this transistor. The transistors are both kept biased on. As the audio signal drives the transistors, one will be driven further into saturation, which will increase the magnetic field on the transformer on one side of the winding. The other transistor will be driven off. And as the waveform goes up and down for positive and negative, the transistors will be switched on and off, just like a conventional Class B or Class AB amplifier would be driven. But because we've only got 12 volts to work with, we don't have the luxury of having plus 12 and minus 12 or plus 40 and minus 40 as in a conventional amplifier. We've just got 12 volts to work with. So how they're increasing the power on this is they're using these as current sinks, drawing a lot of current through the transistor. Maximum current for that transistor at 12 volts will fully saturate this transformer, and then as the waveform swings to the other polarity, to the negative polarity, this one will shut off and this one will come on. And that is how they're increasing the power. They're using the transformer as a means to increase the voltage without the source voltage being higher. So that's just a way of getting more power using a transformer. They're basically using it as a current amplifier as opposed to a voltage amplifier, because our voltage is fixed. We can't go any higher than 12 volts, but we can draw a fair amount of current. But we need to convert that current back to a voltage, and that's what they're doing in the transformer. Transformer is actually what's giving you your power, because the output power on this will not exceed, from the 2 transistors, the output power can't exceed what the transistor is capable of passing. When I had this thing running, I think I was drawing about just a little over an amp. Let me see when I had it at full power, what type of current we were drawing. So 1.5 amps when only one channel is driven. 2.1 when both channels are driven. And we're driving this to just under the clipping point. And with no, see, now we're drawing an amp just at idling current now. So not very efficient, because the amount of current that's passing through those transistors, just to keep the transformers saturated and keep the transistors from going into cutoff, there's a fair amount of power that's wasted. They're almost operating these things almost like a Class A. They're very heavy bias. It's a Class B amplifier, but they're keeping the transistors quite heavily saturated. Like I say, there's no. Right now, there's no power. Like this thing's drawing, 0.8 amps, 800 milliamps. When it's just doing nothing. I just turned the power off to show that it goes to nothing, to 0. As soon as I turn this thing on, right now we're drawing 660. But as the transistors heat up, I think you'll see it'll rise up a little higher. But it's drawing a lot of power just sitting there doing nothing. So the transistors themselves are actually being driven on quite heavily, even though we're not getting any sound at all. And this is just a way that these older power boosters work. They weren't that efficient, but they gave you a little more power than you would normally get by using the transformer to their advantage on this particular design. Other power boosters, and I wish I had another one to show you guys, they basically used 4 output ICs, one configured, and they used a bridge tied load, a BTL, bridge tied load output. This one is not. This is just a conventional ground referenced, because they're using a transformer, ground referenced output. But it's still kind of a neat design, the way that they built these units. I don't want to damage this thing, because I was just looking on eBay. I was trying to find a manual. So I could have gone over a schematic, but I couldn't find any schematics anywhere for any of this unit, any of these type of units. I see manuals for sale, but I don't want to buy one just to get a schematic. But I was looking on eBay, and these things are actually going for a fair bit of money. You wouldn't think that somebody would want to spend money on something like this, but I looked on eBay, and one of them recently went for about $80 for one of these. So I don't want to destroy this thing. If it's worth $80, if some sucker will give me $80 for this thing, they can have it. Hell, if somebody gave me $50 for it, they could probably have it. But anyway, that's a look at this old power amp design. Quite the setup that they're using here. There's the big blocking capacitor there. It's a what is it? 2200 microfarads at 16 volts, and it still works. Not the cleanest of sound, but it is what it is. All these transistors you see down here, all discrete. There's no ICs in this thing at all. It's all discrete parts, but these ones here are all in the equalizer circuit. All these resistors, capacitors, and transistors are all part of the graphic equalizer that this had. And the power meter is over here, and here's the 2 amplifier sections. One channel here and the other, and looks like there's 4, 1, 2, 3, 4, 5, 6 transistors plus the outputs. But here's where the transformer connects, you see. One winding here to the, that's one winding, and the other winding is this one. This one's the one that references ground, and this is the one that references 12 volts. So that's what they've done on this, is say they're using the transformer to double the output that they would get from an individual transistor. And they're able to pull it off using only 12 volts and deliver 60 watts. Now, I kind of think it's probably 60 watts total. They're getting 30 watts per channel out of this, not 60 watts per channel. But still, a single-ended output like this, you could get about 15. So you're still doubling your power. It's just the way they're doing it is kind of neat. It's kind of unique the way they've done it here with the transformer. But that's what we had back then in the technology. See, I wish I had a full schematic so we could actually go through the whole circuit together. But I don't feel like drawing this out. But you get the idea how it works. The output, the driver stage is pretty much like anything else. Nothing special about that. Capacitor coupled driver stage. Anyway, I've probably gone on too long about this old power amp. Anyway, it's kind of neat to look at. And something like this was probably all hand soldered. Made in Hong Kong. You don't see that quality anymore. That was before they made stuff in China. They used to make stuff, well, I mean, Hong Kong, part of China, right? But this was the British side of China, Hong Kong. That's where they made this. Not bad from the early 80s, I would say. Anyway, I've gone on enough about this thing. Questions or comments? We'll catch you in the next one. Bye.